My name is Utkarsh Roy and this is our Bitcoin simulation. Our Bitcoin simulation consists of 100 participants that transact Bitcoins amongst each other and a miner that mines blocks and adds it to the blockchain. We keep a DNS register to keep track of all the participants that are added. The participant get a set of private and public keys that are added here. We use SHA-256 and RIPE-MD to make the keys. Once the participants are added, a Genesis block is created from the first participant. When a Genesis block is created, the first participant gets 100 Satoshis. The update balance method is used to update the balance of each participant. A send Satoshi method is used to initialize a periodic method that sends Satoshis to random participants. This method is called every 2 seconds. This method creates a random participant that receives a Satoshi from the current participant. The participant uses the public key hash of the receiver. This send Satoshi method then sends the Satoshis to the participant. If the sender has enough balance, it will create a transaction added to the transaction list. Otherwise, it will give a insufficient balance warning. The program goes through the unspent UTXOs of the sender to look for the balance. Once the transaction is added to the transaction list, it is sent to the Bitcoin D. The Bitcoin D receives the transaction and adds to its state. The miner module keeps looking for the transaction list from the Bitcoin D. This method is called every 3 seconds. If it gets a transaction list that contains transactions, it creates a block. The block is created using the transaction list. The transaction hashes are used to create the Merkle tree, and the last block is used to give the previous hash and the block height. The structure of the block is here. Once the miner creates the block, it sends it to the Bitcoin D to add it to the blockchain. The Bitcoin D adds the block to the blockchain and then broadcasts it to every participant. The participant adds the blockchain to its state. This process continues and periodically the bitcoins get transacted and the blocks get mined.
Hey, this is Anand. Let's just go through a simulation of the same. We've used the Phoenix Web Framework to do the simulation. So this is a simple web page that runs on localhost 4000 to monitor the transactions and blocks mined by the system. So it's a simple web page where you can find blocks, and this is connected to the backend through a socket. So there's live updates. These are the latest blocks mined by the system, and this is the block height, this is the timestamp of the block when created, these are the number of transactions in the block, and this is the nonce. On clicking one of these URLs, we could further explore the block. Hash, previous hash, and other related information are given here, along with the transaction hashes. This is a stateless client, so on every page transaction, it consults the server for all the blocks. A couple of dynamic charts are also given. So this is a chart of the number of transactions per block, and initially just started off with the Genesis block with one transaction, and as we can see that more the number of participants that receive a balance, more the number of transactions per block. Similarly, there is another metric which quotes the total value per block, and it follows suit with the above graph. These graphs are also dynamic, and they update themselves as blocks are created. So this has been done with the help of sockets provided by the Phoenix framework. A custom router has been built based on the path names to load appropriate JS modules, thereby lazy loading code and thereby running the appropriate code per route. So the socket.js basically updates the charts or the tables as shown here. That's pretty much it. Thank you.